Overview. Extraterrestrial, 2021, focuses on an object that was first spotted in 2017 near the Earth, coming from outside our solar system. Unlike any comet or asteroid previously witnessed, it had an unusual geometry and exhibited an unexpected trajectory away from the Sun. Scientists named it Oumuamua, and it is potentially artificial in origin. Avi Loeb describes why it could be a message in a bottle, notifying humans that we are not alone, and not the most intelligent beings in the universe either. Extraterrestrial details the discovery process, controversies, and potential outcomes involving this interstellar object. Insights from Introduction. Number 1. Many things await us when we simply look up at the celestial objects above us, as they are the inspiration that pushed renowned scientists to make discoveries and change our view of Earth. Number 2. What if scientists focused on the possibility of unknown civilizations beyond our Earth? And if their existence proved to be true, it seems unlikely that humanity would be ready to interact with such beings, which would be the next step. Number 3. Extraterrestrial intelligence is portrayed in a silly way in Hollywood. This popular yet frivolous view has led scientists to brush off serious discussions on a topic that otherwise deserves attention. Number 4. Human extinction on Earth is a scientific certainty, because our sun will die. When that happens, billions of years from now, humans may have already gone extinct at their own hands through environmental degradation, climate change, nuclear war, or other human-made causes. Number 5. The value of evidence relies on what we do with it, rather than our approval of it. Our acquired humbleness from the chase for scientific answers should drive us forward, rather than slow us down. Number 6. Beginning on October the 19th, 2017, throughout 11 days, astronomers observed an interstellar object that flew within our solar system. Insights from Chapter 1. Number 1. The object was given the Hawaiian name Oumuamua, which loosely translates to Scout. Number 2. Hawaii contains the most sophisticated telescopes on Earth. One is Pan-STARRS, which is short for the Panoramic Survey Telescope and Rapid Response System. Pan-STARRS managed to gather the data that initiated Oumuamua's discovery. Unfortunately, by that time, it had already travelled over 20 million miles away from Earth. Number 3. Unlike its predecessors, which were used to track Soviet satellites, Pan-STARRS is used to detect celestial objects threatening to collide with the Earth. Number 4. Scientists were unsure if Oumuamua was a comet or an asteroid until it was finally declared an interstellar object, which is rare. We had never before witnessed anything that had originated outside our solar system. Insights from Chapter 2. Number 1. Life is not a collection of the places you visit. Rather, it is the events that unfold and the choices you make. Number 2. When he was a teenager, Avi Loeb's mother pursued an undergraduate degree, and Loeb would read books from her philosophy course. This caused him to fall in love with philosophy, especially existentialism. Number 3. Philosophy asks fundamental yet unresolvable questions, while science tends to pursue and reach answers. Loeb began leaning away from plans to study philosophy toward science. Number 4. Loeb was drafted into Israel's military. As part of his national service, he began working on military-related science. He met renowned scientists and eventually received a prestigious 5-year fellowship at the Institute of Advanced Studies at Princeton, on the condition that he pursue studies in astrophysics. Number 5. Loeb barely knew anything about astrophysics when he started, but he used his past knowledge to focus on his first major research that tackled how atomic matter is transformed into plasma. He joined the Harvard faculty in 1993 and received tenure after 3 years. Insights from Chapter 3. Number 1. For many astrophysicists, Oumuamua seemed like an open and shut case, considering the minimal evidence that was provided. Most agreed that it was merely a comet or asteroid. Science requires detective work, however, and Loeb did not concede that they were right. Number 2. Scientists did not have a clear photograph of Oumuamua, but they did know how it reflected sunlight. This led to the discovery of its shape, a long yet relatively small object with very hot surface temperature. Number 3. Oumuamua was either elongated or flat, and both shapes had never been seen in any other naturally occurring space object. Somehow, Oumuamua's small size did not affect how luminous it was. Number 4. With no clear explanation, Oumuamua's trajectory deviated in an unexpected way based on the sun's gravitational force. Number 5. Oumuamua's trajectory is important, as it defies the universal laws of physics that should have allowed us to predict its path. Scientists could not explain it, and Loeb formed a controversial hypothesis that Oumuamua is of artificial origin. Number 6. Loeb challenges scientists who oppose his hypothesis on the unusual trajectory by reminding them of past scientific discoveries that were dismissed, yet turned out to be true. An example would be Galileo's theory that the Earth revolves around the Sun. Number 7. Telescopes did not register any trace of Oumuamua disintegrating, which is usually what happens when an interstellar object deviates its trajectory. It had the opposite, in fact, a smooth and steady acceleration. Insights on Chapter 4. Number 1. Loeb and cosmologist Matthias Saldarriaga proposed to eavesdrop on extraterrestrial radio signals in 2007. Number 2. Our civilization emits an abundant amount of radio waves, so perhaps other extraterrestrial civilizations do too. This is what pushed Saldarriaga and Loeb to pursue their research. Number 3. The desert of Western Australia allows the Murchison Wide Field Array (MWA) telescope to be away from radio wave pollution produced by humans using their cell phones and other technological items. Number 4. The search for extraterrestrial intelligence, SETI, faces hostility in the astronomy scene. Conservatism plays a huge part in this, which many astronomers adopt to minimize mistakes in the field and retain their own high acclaim. Number 5. In 2011, astrophysicist Ed Turner and Loeb pondered how they might find artificially produced light with modern telescopes, and discovered that the Hubble Space Telescope is capable of detecting Tokyo's luminosity from the edge of the solar system. Number 6. In 2015, billionaire entrepreneur Yuri Milner invited Loeb to participate in his project called the Breakthrough Starshot Initiative, which aimed to launch a spacecraft to the closest star system, Alpha Centauri, and determine if there was life there. Number 7. Milner's catch was that it had to be done within his lifetime, which proved to be difficult, given that the star system is 4.27 light-years away from Earth. Number 8. The spacecraft had to be light, small, inexpensive, and able to take pictures and send them back to Earth. Number 9. The Starshot Initiative was publicly announced on April 12, 2016. 17 months after that presentation, Oumuamua was discovered by the Pan-STARRS telescope. Insights from Chapter 5. Number 1. Loeb argues that about a quarter of all stars host planets similar to Earth that are also habitable, some of which might contain evidence of previous civilizations. Loeb questions whether Oumuamua might be an artificial engine. Number 2. In 2018, Loeb and researcher Shmuel Bialy hypothesized that Oumuamua represents a new class of thin interstellar material produced either naturally or artificially. If it is artificial, then Oumuamua could be a light sail, one that could have been broken off from advanced technological equipment floating in space. Number 3. Reporters wrote and talked about Loeb and Bialy's hypothesis, which became a big hit in the media, giving Loeb overwhelming attention. Number 4. The media was happy with Loeb's hypothesis that Oumuamua is artificial technology, but his fellow scientists were not, claiming that his theory was baseless. Insights from Chapter 6. Number 1. It is important to determine whether Oumuamua is artificial or not, as the implications will affect both our civilization and science itself. Number 2. We regularly encounter comets and asteroids, meaning there is a significantly vast number of them present in space. The same can be inferred about Oumuamua. If it is a naturally occurring object, that implies the possibility of a great number of other random interstellar objects in space. Number 3. If Oumuamua is a natural object, then it belongs to an unknown class of objects generated by planet formation. Number 4. Shortly after Oumuamua's discovery, another interstellar object, named 2I Borisov, was identified above Crimea. Like Oumuamua, it had a hyperbolic trajectory. Number 5. Velocity position space is a concept stating that the position an object in space holds is defined not only by its location and everything around it, but also by its velocity and the velocity around it. Number 6. If we suppose that Oumuamua was a dry rock, then it was probably gently ejected from its starting point into our star system. This is possible, but statistically unlikely, as pieces of planets do not detach easily. Number 7. The hypothesis that Oumuamua was at local standard of rest, meaning it was relatively still, before encountering our solar system is highly unlikely, which begs the possibility of Oumuamua being a manufactured object designed for a distinct purpose, such as a beacon. Number 8. The origins of an object can be determined through math and a little knowledge of its trajectory. Any intelligent being with a map of the universe could trace back the interstellar ships that humans have launched from the Earth's surface. Number 9. If Oumuamua is natural, then it's a 1 in a million naturally occurring object, based on its unusual data. Loeb hypothesizes that its non-gravitational acceleration was provided by sunlight, the clue being that the excess force acting on Oumuamua declined inversely with the square of its distance from the Sun. Number 10. If solar radiation was the sole cause of its deviated trajectory, then Oumuamua had to be less than a millimeter thick and at least 20 meters wide. Nothing in nature has those dimensions. Only a human-built object fits this description. A light sail. Number 11. The light sail hypothesis opens up possibilities, while the scientific community's favoured comet hypothesis closes them off, which is ultimately restrictive. The judgment is then turned to the practitioners of science rather than the evidence. Insights from Chapter 7. Number 1. If the chances of locating something unusual are very slim, then not searching at all would render that possibility to zero. Number 2. The Drake equation, which is not meant to be solved, estimates the number of actively communicating extraterrestrial civilizations. It is intended as a framework for thinking, and focuses on the transmission of communication signals, which is rather limiting. Number 3. Working on abstractions that have no promise of data feedback is dangerous, as speculations and theories without evidence are against the scientific mainstream. Number 4. The success of scientists is measured by how their proposed theory coincides with the data and evidence, rather than the theory's popularity. That does not mean there is a lack of widely accepted theories with no experimental evidence, however. One example is string theory. Number 5. Billions of dollars have been poured into theories without evidence, and until such an investment is similarly provided for research on extraterrestrial life, then baseless declarations denying Oumuamua's possible origin are invalid. Number 6. Scientists should be inspired by children, who tend to take the kind of intuitive leaps that can propel science and humanity forward. Science is a humble learning experience, and mistakes need to happen in order to open a greater range of possibilities. Number 7. The obstacles that slow scientific progress are often man-made, arrogance being the prime suspect. Number 8. It is wrong of scientists to communicate a finding with the public only after everything about it is certain. Insights from Chapter 8. Number 1. The surroundings that Oumuamua was touring might be the key to unlocking another one of the interstellar object's mysteries. Number 2. The earliest stars came into existence through matter, which was spread across the universe almost uniformly after the Big Bang. This allowed gravity to pull matter into dense regions that formed clouds of gas. The deeper in space a star is located, the older the star is. Number 3. Other than visible light, stars emit ultraviolet radiation, which splits the most abundant element in the universe, hydrogen, into its natural components: electrons and protons. Number 4. Understanding the essential things that make up our universe is key to making sense of extraterrestrial intelligence. If we can do that, then the odds of other beings having done the same are great. Insights from Chapter 9. Number 1. The light sail hypothesis would present two possible explanations if proved to be true. The first being that its creators intentionally targeted our inner solar system, and the second that Oumuamua is a piece of space junk that we coincidentally stumbled on. Number 2. More than 13,000 man-made objects orbiting Earth are tracked by the United States Space Surveillance Network. Number 3. Similar to how humans abandon obsolete items in their daily lives, it is possible that Oumuamua is another civilization's discarded technology that was flung into space. Number 4. Civilization's own ideological advancement could consequently bring about self-destruction. If we are not careful with situations such as climate change, we will not last the following few centuries. Number 5. Humans are insignificant and tiny compared to the known universe and what lies beyond it. We exist for a short time, which is why we must preserve our civilization. Number 6. Winston Churchill wrote an essay stating that many planets existed other than those known in his time. He was too busy with war to publish it, and it was discovered only recently. What if humans had spent their energy on exploring the universe instead of on 2 world wars? Insights from Chapter 10. Number 1. A new branch of astronomy that is the equivalent of space archaeology is long overdue. Astronomers need to start digging into space and searching for remnants from distant, possibly dead civilizations. This could serve as important lessons to help us avoid a similar fate. Number 2. When it comes to extraterrestrial life, what should we be looking for, and where? Subsequently, what kind of life should we be looking for? These questions can be answered through searching for biosignatures and technosignatures. Number 3. Finding a more intelligent life form, rather than a primitive one, would force us to become humble. We can start the search through seeking the origin of life on our planet, otherwise known as terrestrial abiogenesis. Number 4. If we were to find out whether our sun is a typical occurrence in the universe or relatively unique, it would give us an idea whether or not our existence is a result of random chance and help us direct our search more clearly. Number 5. Liquid water is what makes the Earth habitable, and is the starting point in the search for other civilizations. It is more important to focus on where to look, rather than what you are looking for. Number 6. Other promising places where we could seek life would be brown or green dwarf stars. Brown dwarfs are 7% of the mass of our Sun and can cool to planetary temperatures, leading to liquid water, while green dwarfs contain evidence of photosynthesizing plants. Number 7. Perhaps beginning our search with what's right under our nose might prove to be fruitful, as our own solar system might contain valuable information on interstellar objects, shape and motion. Number 8. The technology that helped discover Oumuamua needs a lot of improvement, as it was not designed to discover such objects initially. The more tools we have, the farther we can extend our search. Number 9. It would be naive to assume that other civilizations will not be hostile towards us, as our violent human history precedes us. Number 10. We cannot allow the familiar to stagnate our readiness for the possibility of finding much more advanced technology. If we are not prepared through research and discovery, then our process will be much slower, costing us time and energy. Number 11. The adult mindset that has lost enthusiasm and love for new challenges is setting us back. Insights from Chapter 11. Number 1. It is better to live life as if far more intelligent beings other than humans exist, than to ignore this idea completely. Betting on Oumuamua's possible connection to such intelligent life is but a modest leap of hope for scientific evidence. Number 2. Would humans prefer to find extraterrestrial civilizations that are religious or secular? Judging by our history, alien intelligence is likely to be both. Number 3. It is probable that alien civilizations would be just as awed by our existence, just as worried about our intentions, and possibly be just as existential as we are. Number 4. Through thinking of other civilizations' values, we can refine our own. Insights from Chapter 12. Number 1. Discovering alien life would allow us to expand the field of astronomy, with tools such as astrolinguistics, astropolitics, astroeconomics, astrosociology, astropsychology, and so on. Number 2. Unfortunately, humans have spent most of their investment and time developing means to destroy life, not preserve it. This means we are extremely vulnerable to catastrophe. There is no reason to assume that terrestrial life is optimal. Number 3. Scientific evidence should encourage us to not dismiss the possibility that humans are of Martian origin, or beyond, Safe bets are limiting and uninspiring. We can only gain from placing ambitious wagers. Insights from Chapter 13. Number 1. The data on Oumuamua is inconclusive but substantial, the main focus being its deviation. The scientific community rejects the idea that it is artificial because they themselves did not manufacture it. Number 2. Achieving what seems to be impossible is in arm's reach when humanity works together, just as it was possible to capture the very first photo of a black hole in 2019. Number 3. To conquer future challenges, we need to cultivate as many bright minds as possible, and this will be impossible if our discoveries and ongoing research are not made public, especially since the bulk of our research is funded by the public. Number 4. Science is a humbling endeavour that belongs to all, regardless of academic background. If we do not ask the big questions, then civilization will never get the answers and the detective work continues. Author's style. Avi Loeb explains complex mathematics and concepts in physics through personal anecdotes, research papers, analogies, images, and charts. The 13 chapters encompass his personal journey and how it ties in with Oumuamua, the scientific community, and extraterrestrials. He aims to both inform laypeople and convince specialists in the field. Author's perspective. Avi Loeb grew up on a farm in Israel and was inspired by existentialist philosophy, which taught him the importance of being humble. After being drafted for national service, he caught the military's attention with his scientific innovation regarding missile defense concepts. He became the longest-serving chair of the Harvard Astronomy Department, with many scientific accomplishments. He firmly believes that the public should be aware of ongoing scientific research. He also wants to inspire young, scientific-minded intellectuals in order to advance the field and to encourage a humble, ever-growing way of thinking. We hope you enjoyed the insights on Avi Loeb's Extraterrestrial. Purchase the book to learn more.